It is flashing, so hopefully it is recording. All right. Welcome, everybody. We're back. And we're at day 3 of the first week. So by now, it's starting to be less crazy and chaotic, right?
The fog.
Yeah, less crazy and chaotic. We'll find out. Just so you know, I'm going to be doing a few things different this semester than I did last semester. Last semester, there was no way, no how, no possible way. It is impossible, as you all well learned, that I could not give a comprehensive exam for the final. That is not the case this semester. The topics as we go through Physics 2 are pretty desperate. And you know, they're far-reaching. They're a little bit, while they all come together at the end, sort of, the way we deal with the topics, it's not that way. So we're actually going to go through a variety of topics, and we'll test over those topics, and there will not be a comprehensive final. Okay? The final actually is going to be totally over optics. When we get that in, you'll end up with optics as the final. So it's going to be a little different in how this semester runs from that perspective. Now, some of you struggled mightily with mechanics because you're wired a little differently. And there are a lot of folks that Physics 2 is actually easier for them. They just get it. There are a lot of folks that Physics 2 it's tough. I will tell you, I am a person that mechanics was easy. Physics 2, I had to learn almost entirely through parallelism, which is really weird because all of my graduate work is done in optics and electromagnetism. All of my work outside has all been in electricity and magnetism and optics. I'm actually a light scatterer by training. That's what I do, or what I did. And so it seems a little odd that even all of my theoretical work was in electricity and magnetism, yet it's not where my happy place is. My happy place happens to be on the mechanics side. I'm just a glutton for punishment. That's just the case there. So there are going to be a few things that are different. And I do read the comments that people give me on my instructor evaluations. And as such, we're going to talk about a couple of them that I got that are kind of negative comments. One of which I have very little control over, and that's how fast that I have to go in order to get the material. That's something I got to get us through a certain amount of material, because when you get to your junior and senior level classes, they're going to have expected you to have had that in general physics. And so that I really have very little control over. Yeah, I can extend time on certain things. Yeah, I can compress time on other things. But at the end of the day, we got to get to optics. And that's where we got to be. And the same way on the mechanics side. At the end of the day, I had to get us through in 16 weeks through there. So that's something that I have not as much control over, and is how fast that I cover the material. And that's just the fact of life. But there are things that I do have a little bit of control over. And as such, I'm implementing a few things that may help the situation. So, thing number 1 is I'm going to use my computer instead of the desktop computer in here. And I'm going to open up to Blackboard. So this is Blackboard. This is when you come into the home site. Please, if you haven't already, get into WebAssign and make sure that you can get into WebAssign and that you're not having trouble. In my Engineering Physics 1 class, we are experiencing one glitch, which is better than what we had last semester trying to deal with Cengage Unlimited and things like that. If you had a Cengage 1 semester unlimited subscription, and it's 1 semester only, not a multi-term, you may have a glitch in being able to see the course. So by the end of the day, please, please, please try to get into WebAssign if you haven't already and are able to see the course. Because we are trying to get that corrected, and we're trying to get that corrected as fast as possible. And let me know if you are running into that problem, because you shouldn't have an issue with that at all. The other thing is, if you do have Cengage Unlimited through like digital and financial literacy or through another class, you will want to opt out of this class, because this class is not this class is being direct billed to you right now, and it is not, and you don't want to be double billed on your Bursar account for that. If you have more than 2 classes in Cengage, it is worth it to you to go to the bookstore to go buy a 1 semester Cengage Unlimited, because it's going to be cheaper. So if you have 2 books or more in Cengage, you'll want an unlimited subscription because it's going to be cheaper in the long run. If you have unlimited direct bill, like through digital and financial literacy, you'll want to go ahead and opt out here. And if you've got questions, you can go to the bookstore. And the way you opt out is there was an email sent to you through the bookstore system that says, okay, do you want to be billed for this semester? And you want to make sure that you're there. Yeah.
I was having a glitch, but I went through and I still have an account, so then I went in and I had to go and find me, and then I had to put in the key, but I had unlimited, and then I got an email saying that my Cengage was, so I bought it, the unlimited, but something, I don't know if.
We'll talk about it specifically afterwards, okay?
Yeah.
Because if you had a Cengage Unlimited subscription last semester, you had to know whether you had a multi-term that went more than 1 term or just a single term. And that's one of the places that we're, a lot of my students have a multi-term, which means that it was just a breeze to get back in here. Some of you just got through via direct bill, which is a breeze to get in. But we want to make sure that you have the access and get into access. So double check and get there.
Dr. Black?
Yeah.
Hey, it's Robin and Enid. We've lost you. Not lost you, but just your screen is completely black, and I'm not sure if you switched screens before I called the help desk.
Let's see. Let me do this again.
You're fine. We just lost the visual of you.
Okay, but it did start with the visual?
Yes, we've been fine until the last, 3 minutes.
Okay, well, I'm going to call the room.
No, you were explaining something and they didn't see it. I was looking down.
Okay, not a problem.
Anyway, let me know if I need to go.
Okay, well, interestingly enough, we've lost the phone.
Oh, let me see if mine works.
Yeah, see if yours works. Which is probably why you lost the screen if I've lost the phone.
Yeah, Jen, I got the desk. Hang on. This is Robin and Enid, and we've lost the visual of Dr. Woodblood's. We had it this morning. We can still hear her. We're still connected, we think. We just don't have a visual. It's completely black screen. And it has a.
And if you'll let them know that my phone is not working in my room as well, so I'm guessing that's part of the problem. I'm going to switch to the document camera and let's see if that'll work. Maybe. Okay, do you guys still have black screen over there in Enid?
Yes.
Okay, because it switched to the document camera over here, but it is not switching over there.
Yeah, I just went black in the middle. And she didn't switch screens or anything. She was just.
Yeah, I didn't. We just dropped it.
And then she went to call the help desk. Yeah, the phone in the classroom. All right. they're gonna get on it, so maybe if you
All right, let's see what's going on here. Yeah, because my phone, I just unplugged the phone and everything and try to plug it back in, see, because that's our internet connection.
But it sounds like they're starting to look into it.
Well, we had trouble with this room on Monday as well.
Oh,
I started recording, I really did start recording, but it only recorded for 15 minutes.
I assume you don't see us, huh?
No, I see you guys. I can actually see,
All my students.
yeah, I can see the students on my confidence camera on the one screen. The phone is rebooting up. Okay, there we go. All right, I'm gonna try this. So now I have phone back. Now on the confidence monitor, it says it's sending out my laptop. Are you guys still got blank screen?
Yes, blank screen.
Okay, let me do teacher camera and see what happens.
All right, we're back.
All right.
All right, I'm gonna call the help desk just for fun. Oh, now we're away. We're gone.
Now you're gone. Okay, that's interesting.
But when you went to the teacher camera.
When I went to the teacher camera, it worked, but not when so it's something in the,
Document.
okay, the document camera should be up.
No, ma'am. I mean, not here.
Try desktop computer, see what happens.
We see the computer with,
Okay, you see that computer?
sign on with Kim though, yeah. Okay, I almost saw the document. Oh,
Yeah, I'm changing stuff.
flip it.
Okay,
Black,
you seeing anything now?
black screen. But it was flipping. I saw a computer screen. I saw,
Okay, so that's interesting.
you know what I mean? I saw the document camera just for a free.
All right, let's see what's happening here. We can go there and see while they figure it out. There's more ways than one to get what we need to do. Okay. Okay, can you see the desktop computer?
Yes.
Okay, well, we'll start with that. So, we get the blackboard here. Hey, woohoo. All right. Oh, wrong class. We're in that class. Okay, so we're back to Blackboard. Okay, so one of the things that people have had, okay, they can see this screen.
So it came back up?
That came back up. Well, I unplugged the phone and plugged the phone back in because the phone was totally gone.
That's what I was gonna do.
And I did that. But now if I try to do mobile device to get my laptop up on the screen, it shows, well, it's going to give it a second. Now we're getting black on the confidence monitor. Now we're getting black on my computer. Okay, there's my computer. Okay, so we got that. Now, do you have black screen or do you have my computer?
I have a black screen.
And they have a black screen. But they can see the document camera when I switch to the document camera.
Don't do it so fast.
Don't do it so fast.
Don't move
Hey.
so fast.
They should be able to see that here in just a second. You got the document camera over there?
No,
It's gotta go all the way to Enid.
It's gotta go all the way to Enid.
It's foggy out.
It's okay. I know there's a delay because the speed of light.
Did you get here as fast as you normally do?
The fog does not change it through the wires.
You don't know that.
You don't know
It
that.
still does. I will tell you that from here to here, for those of you who can see the document camera, 11 inches is roughly 1 nanosecond in terms of speed of light.
What do you got now, Enid?
black screen,
Okay, switch to teaching.
sure.
Well, you see Robin?
Yeah, I think you guys can see me.
Okay, now toggle through like your computer. Switch to computer.
Oh, okay, I see what you're saying. Well, first I'm gonna do desktop computer.
Okay,
On my-
now switch to document camera.
Interesting, it's not on our screen.
Okay, now switch back to the red button, the video. Okay, now switch back to the receiving.
Okay, I have my classroom on my confidence monitor, and you guys are still black. There is a symbol in the very left top-hand corner, and it almost looks like a lock sign. But I can't tell, because it's up in the air and. What kind of
Oh, I
symbol?
see it on ours too.
What are you
You
talking
see
about?
that symbol?
Like you see on our monitor, up in the top corner.
Like a lock. Like something's locked, but
Well,
I
let me go back down to control
Looks like a
since you
key.
got your phone.
No.
Oh, yeah, it does look like a lock.
Yeah, it does look like a lock. Okay, I'm gonna go to the desktop computer. He's gonna go back to control and see if it's something on that side. Let's see if you can see the desktop computer.
yes, you can.
Okay, we got that part. Woo! All right, so we'll just go on. So yes, 1 nanosecond is about 11 inches. So, yes, it does take a little time to get to Enid, but not that much. All right, so this is our blackboard. You can go into the syllabus, wrong mouse. Go into the syllabus. There is a change in the grading scale, just ever so slightly. So I'm going to open it up. I had it open on my laptop, but you know how that works. Okay, we're going to do read-only copy. There we go. The difference this semester from last semester is last semester down here, homework was like 20% of the grade, quizzes were 20% of the grade, and the final was 20% of the grade. I've made a shift because the final's only over optics. Homework is going to be 25% of the grade, quizzes are going to be 25% of the grade, and then everything else is, and then the final's not worth 20% of the grade, it's only worth 10% of the grade. So you have a little bit more control over your grade, and I will tell you that quizzes will be a mix of in-class versus online quizzes. That also being said, the exams will be a mix of in-class and take-home, because there's at least one exam that I don't think it's fair to have you try to do the exam in a 1 hour or a 1 hour and 20-minute time slot. When we get to circuits and you're trying to work with circuits, the problem that you end up with there is that the problems aren't difficult, they're tedious. And if you start down the wrong path, you've used up all your time. So I don't feel that it's fair to force you to try and do that exam in a fixed time period. Because if you pick the wrong route to do it, or you pick the wrong loop, you're sunk. And I just don't feel like that one's fair. So we do have that. I will shoot for 4 exams plus the final. It may or may not work out that way, because as things progress through the semester, We know how that works out, but I shoot for 5 exams in Physics 2. And sometimes it works, sometimes it doesn't, but that's what I do. But the grading scale itself, that 87.5 to 100, is going to stay the same as it has last semester. Similarly, the bonus points in WebAssign are there 48 hours in advance, and you get your bonus points. So that's another way to get things. So those are the changes from the normal stuff that we had before. Under instructor information, you guys have my office hours. I am on Enid campus for you guys over in Enid. I'll get there before 8 o'clock, and I'm there until probably at least 3 o'clock. And from 9:30 to 12:30, I may be in the physics lab, and if you need help or need something, I'll be over in that physics lab because I'll be running the engineering physics lab, but you're more than welcome to come on in if you have a question or need help over there. So I'm there on the Enid campus all day Fridays. Just so you guys know, and this was one of the comments that I got in my reviews, is that when you guys send me an email, I'm not very helpful. Okay, let's talk about that for a second. Because I have implemented an email policy that hopefully will make me more helpful. I teach Engineering Physics 1, General Physics 1, General Physics 2, Statics, Engineering Mechanics, and a couple of labs, plus an online course this semester. So that's 7 courses that I teach. I teach courses that go back and forth between 2 campuses. I've had you guys for a semester, so I'm starting to recognize names, and I'm starting to put names in the right classes. But guess what? That's a lot of students to keep track of. So what happens is I get an email. I'm having trouble. Okay, I understand that. Which class are you in, and what exactly are you having trouble with? Then I'm having trouble with problem number 3. All right, you guys know, right now today, you have 3 open assignments for you guys in WebAssign. Okay? That means there's 3 potentials for problem number 3. Okay? So it ends up I have to do a bit of detective work to figure out which problem number 3 are you talking about, which class are you in, and that makes it a little difficult for me. All right, so that's why I've implemented an email policy. Please let me know which class you're in. Please let me know which assignment it is. And please let me know which campus you're on. Because I don't want to feel stupid when I say, well, I'm in my office right now, and why don't you just come on over, and I'm on the wrong campus. Because I do get to see everybody. So I can't, sometimes I don't remember which campus. So that's going to help me out helping you out. Okay? That's going to help me out helping you out. All right, I'm hoping we can see the document camera because I want to talk about something else. Well, we'll wait until he calls me back because there's a third part of that complaint about me saying, well, all she does is refer me back to the book. And I'm going to talk about that here in just a little bit. As soon as because I need my document camera for that one. So we'll get there. The other thing that I'm doing that hopefully will help you guys out, and I've already gotten a couple of responses from it, is there's the schedule a meeting with me link. And that is linked directly to my calendar. So that if there is a time that you've got, instead of doing 5 emails, are you going to be in your office at 10:30? I really need some help. Or you're going to be in your office at 9:30. It's going to save you time, save me time. And all you have to do is click on the link. See if it's going to do it. Come on. I do know there it is. And it will open up my calendar. And you can click on the day. And you can click a 30-minute time period. And this will work whether you want to do a virtual office through our Zoom product, which is how we actually communicate back and forth via ITV, but it works like FaceTime. And on my laptop, I actually have a whiteboard function that I can actually write and share a whiteboard with you to actually share a problem. So, so if you want to do it, a virtual meeting, then, and if it happens that you need an evening time slot, we might be able to work something out. So that's one of the things that this, hopefully this will also help. Because there are going to be times that some of this stuff is going to go, okay, I'm not getting it, I'm not seeing it in my head, and hopefully this will help out a lot in order to go back and forth and deal with, being able to help with different things. So that's one of the things that I've implemented this semester. And you've got that schedule link is under instructor information on Blackboard, and it's, oh, I haven't put it on this one yet. I thought I had put it on all my classes over here in the left bar, but I will get it over there as well for you guys so that you guys have it, so that you can just click it there and schedule a meeting. So hopefully those two things will help. The other thing that's helpful for me is if you're having trouble with WebAssign, or you're having trouble, if you take a picture of your work or take a screenshot of WebAssign, that also helps me out to be able to tell you whether it's just a formatting error in WebAssign, or if we got to find the square root of 2, you forgot to square something or something along those lines. Hopefully that will help quite a bit from that perspective. So under course material and assignments, there's your link for WebAssign. There's the link to all my past Physics 2 lectures. So if this lecture didn't work out for you, or this explanation didn't work out, or there was a problem that I might have explained a little differently, you have access to all my YouTube past Physics 2s to YouTubes. And I should have these up fairly quickly as well, trying to get those in there. And then under week 1, you'll have a variety of links to old lectures, resources, the same types of things that we've had in the past.
I never saw the PowerPoints, is that on the,
That one's hidden from you guys.
okay.
It says hidden from students. It says hidden from students. And part of that is I don't always use my PowerPoints. I have them there, for like things like today, where we can only use the computer. I might have to actually dive into those. And that was another, just so you guys know, that was another issue that I don't hand out PowerPoints. Sorry guys. Physics and PowerPoints don't necessarily go together. Some pictures do, but physics and PowerPoints don't necessarily go together. It's kind of that problem-solving class that's in there. And one of the other things that we're trying to do is get you able to, note-taking and note-taking skills are dying. They're dying because of PowerPoint. And when you get up to some of your upper division classes, or you're in clinicals, or you're in internships, or you're in other things, they're not going to hand you a PowerPoint. And so note-taking skills are another thing that they're dying because they don't have. I had to take notes in high school. Sorry, way back when, long time ago, because A, we didn't have computers in class. We had the old crank overhead projectors, with the acetate, or chalkboards. So, I mean, and actually, that makes it sound like it was so ancient. We were still using chalkboards and stuff until the late 90s. Computers in classrooms really didn't hit until about 2008. So, I mean, it doesn't take that long ago that we were all still taking notes. All right, I'm going to take a gamble here, and let's switch to the document camera.
Yes.
Yay! Woohoo! All right. We got the document camera. Okay, so one of the other comments was, I asked a question, and she didn't help me. Okay, it turns out that's a universal problem. It's not just me, and it's not just physics. Because I was actually discussing it with one of the literature instructors, and they say, yeah, we'll read a passage, and the student will come up to me and say, I don't get it. Okay? Well, my son, you guys have heard about my son. My son is currently working on his PhD at Oklahoma State, and he's working on his PhD at Oklahoma State in the brain chemistry of learning. He's an experimental psychologist. He's doing experimental psychology. He's actually looking at the brain chemistry that happens when we're learning. And so we had this discussion about how do we help people to ask questions? And how do we help so that I as an instructor can actually help you ask the question? So we had a long conversation over break trying to figure this out. So we came up with an analogy. Almost everybody, show of hands, everybody's played with Legos, right? We've all played with Legos. You know, okay, so this happens to be a Lego set. Brand new out of the box Lego set. So we can think of it as brand new out of the box physics book. And we're starting to work on a problem. Okay? We've got all the tools to solve the problem right there. And so what usually happens is somebody will come in, and I want you to put yourself in the instructor's hat. You are the instructor. And in this case, we can put the 4-year-old, because this particular kit goes from 4 to 99. Okay, this particular kit's 4 to 99. And the person comes up to you and says, I don't get how to do it. What's the first question you're going to ask yourself? What's the first question you're going to ask me if I come up to you and say, I don't know how to do it?
What part don't you understand?
Huh?
What part don't you understand?
Well, okay, I got a pile here.
Did you look at the instructions?
Well, I got to, did you look at the instructions? Well, okay, that's okay too, but this is a creator's kit. Okay, this is a creator's kit. That's what my physics book is. My physics book is a creator's kit, or my literature book is a, what's the first thing you're going to ask the person?
Did you try to put it together?
Did I try to put it together?
Did you work on it?
Did I work on it?
Show me some work?
I gotta know what I'm building, don't I?
Yeah.
So my first question is, what am I building? Or what is it I'm trying to do? Okay? What is it I'm trying to do? So this is a creator's kit. This is a creator's kit that allows me to build an alligator, a truck, or a building. So first thing I got to know is, where am I going? What am I trying to do? Okay, that's first thing. And so you start with that question. So now the person says, okay, I'm going to try and build the truck. All right? So now what's the question that you ask? Or what's the suggestion that you're going to have?
Are we the teacher?
Yeah, you're the teacher.
I start with the biggest piece.
Well, so somebody's going to say, let's get the pieces, right? That's one thing. Somebody's going to say, let's get the instructions out, because that's what you said, right? Get the instructions out. All right, so this is a Lego kit, right? So this Lego kit does have instructions. So we're gonna open up the instructions here, and we're gonna try to build the car here. There's our car. There's our instructions. And so the first thing that we got to do for building our Lego piece is pull out of this pile the things we're going to need. Right? That's the first thing we got to do, is pull out of this pile of things we're going to need. And that's one of the things that we have. That's our toolkit that we've been building for the last year. We've been building that toolkit. We've got things that we're going to need, and we're going to have to use it to get there. So we got to pull that out there. Now, First thing I'm going to do when you ask me a question, well, what is it you're trying to do? Okay, that's first thing. What is it you're trying to do? What is it you're trying to build? And the second thing is, all right, I'm going to point you to an example that's close. That's the instructions. And then if you're still having problems, which is what usually will happen, is I'll point you to an example, and then somebody would, I never hear from them again. Well, it turns out that that person got frustrated, and I never hear from them again, so I don't know whether or not they had a trouble to get there. And what's happening is this. All right, so we've got steps 1, 2, and 3. I've gone to Chegg, okay? I've gone to Chegg, and I'm getting steps 1, 2, and 3. And then Chegg goes from step 3 to step 8,
Yeah.
right? They skip a whole bunch of steps. Sometimes the example does that too. Sometimes the example in the book, due to space or whatever, has done that as well. But if you come back and say, I don't know how they got from step 3, I can get here just fine, but I don't know what they did to get here. That helps me help you figure out how to get from step 1, 2, and 3. All right? That's where, and it turns out when we came up with this analogy, looking at the Lego set, because all of us have dealt with Legos, all of us dealt with little kids trying to solve a problem, that you start getting, okay, I know that this is what we're getting. And it turns out, really, when we went to the literature, to actually look at the literature from a psychology point of view, on how to help people ask good questions, there's not a whole lot out there. I told my son, I said, there's a great research project. There's a lot of stuff out there from a teacher's point of view to ask questions, because I've been doing it. What is the first thing that you're going to do? That's a question to get you guys engaged. But there's not a whole lot of us being able to, as instructors, being able to help you ask a good question, so that we can turn around and actually help you get from step 3 to step 8. So this is a case of, here's my example in the book, here's what Chegg does, right? It cuts out some of the things, but here's what the homework problems are. The homework problems are taking it and saying, okay, here are other things that you can build. Now, I happen to have the green set, and I didn't mix it with the orange set, but I have the same types of pieces, so I could build this puppy dog piece out of the pieces that I already have, but I don't have instructions for it.
Yeah.
It's an extension of what was given in the instructions.
Right.
So hopefully this gives you an idea of, if you've got a question, I'm really not trying to put you off. I really am not. And going back and forth through email, and as you can see, okay, I'm trying to do problem number 3. Okay, I got it. But which problem number 3 are you trying? And then I don't know what your problem is. Is it because WebAssign is not taking that exponent, as you all have dealt with, right? Or I have typed in the expression and WebAssign is counting it wrong, but I'm looking at it and I'm sure that it's right. And that's just a WebAssign formatting problem. That's easy enough. If you took a screenshot, I can go, oh, it's a WebAssign formatting problem. Don't fight it anymore. I'll give you credit for it. Or I've got the problem, I'm working the problem, and I don't see where my mistake is, and I keep getting it wrong. And I'm going to tell you right now, in electricity and in magnetism, if you have the wrong sign, if you've added where you should have subtracted, that's going to cause you a problem in your answer, and that's going to be hard for you to find. And the only way I'm going to be able to help you with that is to be able to see your work. Because we're going to be looking for, well, should I have used a positive or a negative? Okay? And I will warn you, when we get to circuits, there's some messy algebra. It's tedious algebra. And there's always a place when we're doing tedious algebra, guess what? I've forgotten to subtract when I put it to the other side of the equation.
Mm-hmm.
So I'm going to need some help from you guys in order for me to help you guys better. Okay? So now, this was an experiment. I tried this experiment on Monday. My Monday's class really, really loved it. did this explanation help you guys out a little bit?
Yeah.
I've got nods. Okay. Yeah, my son and I worked on this, so I have to give my psychologist son some credit. I have to give my psychologist son some credit because we really worked and talked through it and tried to figure out, because this is something that we discovered there's not a whole lot of educational research out there on, which astonished me, but then again, I'm a physical scientist.
Well, I just feel that most of the textbooks, they do that intentionally for you to do a lot of learning on your own.
Yeah.
Yeah, so.
And that's one of the challenges that we have. It's definitely my grandkids, of course, are going to love me because I bought several different Lego sets to try and figure out which Lego sets would work. So, all right. And the other thing that I'm going to do a little differently is I've got something new in new gizmo, and because of my new gizmo. I think I'm going to be able to do more demonstrations in class. So let's go back to the teacher camera. Let's see if we got it going here. Hopefully you guys can see me. Can you see me over there?
Yes.
All right. And you guys can see the other class over there. We're pretty evenly split between the two campuses, which makes it kind of fun. All right, everybody cool with the good old logistics and the information, where to find stuff, all that good stuff? Because we're about to dive in to Physics 2. Yeah.
So, for the web assign, do we just need to go to the library and get one of those cards again?
The bookstore?
Yeah.
Well, actually, you should have the course key and your direct build for it in here, unless you want to do a Cengage Unlimited, and then you go to the bookstore to get a Cengage Unlimited.
Okay.
And where do you see the direct bill at?
The direct bill, it's going to be direct bill to your account, and the course key is in a couple of different places in Blackboard to get your course key. Now, if you want, I did make Cengage Unlimited optional. If you have more than one class in Cengage Unlimited, and then you go to the bookstore, get your optional Cengage Unlimited, and then you opt out of the direct bill so that you're not billed twice. And they'll also tell you which books, because it's not 100% clear which ones are Cengage. If you're using MindTap, a couple of other things. If you're using Connect, it's McGraw-Hill, and that's not part of the Cengage Unlimited. If you're using a Pearson book, it is not part of the Cengage Unlimited, and that's like mastering. But we have an awful lot of textbooks on campus that are Cengage. But if you're in mostly your biology classes, most of your biology classes are McGraw-Hill. And so unless you have two Cengage classes, then Unlimited is definitely your cost-effective choice if you have at least two Cengage classes. Okay? All right, you guys got any questions over there in Enid about logistics? Because we're about to dive in. Okay. All right, so let's think about where we were, what we covered last semester. Covered mechanics last semester. But there's one thing that I don't cover in mechanics and this is one of those cases where depending on where you break Physics 1 and Physics 2, between the two semesters, you may or may not get this. But we did do something in Physics 1 that we're going to start with right away. Remember Hooke's Law, right? Remember Hooke's Law. That's the law about our spring. That if I have a weight on my spring and I stretch it, that there's going to be a restoring force and it's going to want to pull it back up. So we're going to have that stretch of the spring and we're going to want to pull it back up. Well, in mechanics, which is what we covered most of last semester, we dealt with mechanics. So we dealt with velocity, acceleration, forces, and we dealt with them in two different ways. One, we dealt with them in what we call translational, moving in the X and Y and Z directions. And we got into rotational, right? We started going around the circles. So we had translational motion and we had rotational motion. And we started talking about things like that angular velocity. How fast did something go around the circle? How fast did, that angular acceleration in rotational? And we dealt with, okay, if I'm further and further out on the circle, remember we talked about the merry-go-round or the merry-go-round, and as my linear speed would increase if I'm way outside on the circumference of the circle, it's very different than if I'm very, very close to the center of the circle. And we talked about and we looked at those things. Well, we're going to start looking at leading up to electricity and magnetism. So where I'm going to start is I'm going to start with basic waves. And we're going to start with simple harmonic motion. And simple harmonic motion is abbreviated SHM. And we are all familiar with simple harmonic motion because we've dealt with it. And actually one of your assignments that you're going to have is to give me a picture or an example of simple harmonic motion. Now, what's the most common example of simple harmonic motion that you can think of?
Wind chimes. Spring.
Well, let's see. Okay, I'm going to give you an example of simple harmonic motion right now. I've got this lovely, you guys can see me over there. I've got this lovely red box. It's attached to a spring, and it's bouncing up and down. I'm about to switch over so you can actually see it. Make sure it's on. Okay, we got it on. So I've got it lovely, bouncing up and down. And that's an example of simple harmonic motion. A pendulum swinging back and forth is simple harmonic motion. But we use simple harmonic motion a lot. Okay? We use simple harmonic motion a lot. We actually can represent numerous things as examples of simple harmonic motion. And so you'll see it in chemistry, you'll see it in mechanics, you'll see it in you can actually look at an EKG, and there's some evidence of a repetitive pattern that happens, and you can actually write those patterns out, those wave patterns, and we can interpret them different ways, and we're going to look at simple harmonic motion. So one of your assignments is to give me an example of simple harmonic motion, and I'm going to tell you that you cannot use the pendulum of a clock. That one's too obvious. You can create your example of simple harmonic motion. I'm okay with that. You can go out on the internet and look for examples of simple harmonic motion. I'm okay with that. But there's a lot of examples of simple harmonic motion. All right, we're going to tempt fates. We're going to go to my laptop. And this is why I'm hoping things will get through. This little red box that I've got is actually a physics lab.
This is what black,
Yeah,
it's black again.
it's black. No! 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 No!
Call the guy again.
No. Okay. Well, give me a minute. Pause here.
Yeah, and the health room thinks everything's solved.
I know. Yeah, it's okay. It's all right. I'm going to go ahead and do this because I'm going to be in this room. So we are going to do this. I'm going to see if I can get this done. Okay, there we go. I'm going to do it. It won't take long because I did this yesterday on my laptop in class or in there. Now, I'll switch this so you guys can look at this lovely little thing, this lovely little gizmo. Maybe? Okay, this red box.
Oh, we're a black screen still, sorry.
Your black screen? Okay. It died again. But this, so I've got a little red box. I'll bring it with me over there to Enid so you guys can see it. It essentially is a lot like the Logger Pro that we have in the physics lab, except all of the sensors are actually in this box. So I have an accelerometer in this box. I actually have a gyroscope in this box. It's also got, which is one of the reasons I really was excited about it, it's also got things that I can do some electrical things. It's got a light sensor. It's got a sound sensor in it. So it's going to hopefully allow us to do more demonstrations physically in class that I don't have to bring a whole lot of equipment over to be able to show you some of the stuff. So I'm hoping that we can actually do some more hands-on type pieces with this. And it's really kind of a cool little gizmo that I obtained. All right, we're going to do this because we seem to be able to use this computer. So I'm going to, okay. All right. Double click and open on the execute. Okay,
Oh, here comes help.
here comes help.
Yeah, no, we have audio, but we do not have visual again, and it's, her end, or, you know, when she starts to switch, yeah.
There we go.
We'll be teaching in that classroom on the next hour, so maybe we need to keep.
Yeah, we will be teaching in here next hour. Okay, let's see.
She wasn't just a second ago, because she can hear me talk.
All right.
Dr. Woodblack, is your phone working?
Yep, my phone is on.
Phone is on. Yes. Okay, what are you seeing in your room? Are you seeing our?
I've got my document camera up. Let's see what I've got. I'm going to close everything out here.
Visual to us. Oh.
Okay, it's paired. I'll make sure it's on.
He's gonna keep working on it. He may have you, between classes, turn the whole system down and.
And restart it.
Yeah, so, I'm sorry, but.
Okay, looks like I've got it up and running. So if I do my accelerometer, there we go. All right. I'm going to switch. Hopefully you'll see the desktop.
Yes.
All right, we've got that one. Okay, so I've got my little red box, my little red Gidget box that you guys saw at least from the piece. On the screen right now, you have the accelerometer. I'm going to hit the record, and I'm going to start it in simple harmonic motion. And we'll stop it. Okay?
Pretty cool.
So basically what it was doing was exactly what I showed you guys when we started. The red box was bouncing up and down on that screen.
Mm-hmm.
And we collected it with the accelerometer. And that we've got a nice up and down pattern that we have in here. And it's giving you, and notice it's giving you 3 dimensionals, because this thing is recording in 3 dimensions. It's recording in the X dimension, the Y dimension, and the Z dimension. We don't have, we've got a little bit of fluctuation in the z dimension, but we didn't go anywhere in the x dimension, right? It's pretty much on top of the z dimension, because really we were bouncing up and down in the y direction. That's basically what we were doing. But we've seen that kind of wave function before, usually in math class. What is that function? If I were in math class, what is that function that math class is going to tell you it is? If I'm using my graphic calculator, how am I going to get something that looks like that? Oh, come on, people.
I'm trying to think.
No, well, yeah, I've got parabola, but if I want my graphic, this is a function of time, right? This is a function of time.
Acceleration?
No, don't worry about a physical quantity. Don't worry about a physical quantity. If I'm in math class and math class puts that up there, what is it?
Cosine.
I've got a cosine.
Cosine, oh, okay.
I got a cosine. Oh, it could also be what?
Quadratic?
If I've got cosine, it can also be what?
Coefficients,
I'm hearing whispering. Come on.
Tangent.
Nah, tangent doesn't look like that. Tangent's weird.
Sine.
Sine. This could either be sine or cosine. The only difference between sine and cosine is what? My trigonometry identities say that the sine of the angle plus, or if I have sine angle plus 90 degrees, it's equal to the cosine. Or if I do cosine plus the angle plus 90 degrees, it's equal to the sine. The only difference between sine and cosine is whether I start at 1 or I start at 0. That's it. They're considered to be either in phase or out of phase. My cosine is 90 degrees off or out of phase with my sine. So it doesn't matter. I can represent that wave right there. And I'm going to go ahead and switch to the teacher camera, and I'm going to move the teacher camera around, and let's see what's going to happen. Let's see. And then if I get teacher camera, I want teacher camera. I don't want the students on the screen. I want my screen on the screen. See if that does it. Nope, wrong way. Teacher camera. And I want the teacher camera on the front screen.
Black again and it can.
Yeah, I know, I pushed the wrong button. I'm trying to figure out how I can have that screen and me on the same time without switching, having the students put up there.
Yeah.
Let's see. Hello. Yeah, well, I'll reboot it between classes, but now I'm trying to put the teacher camera on me, but leave the desktop computer on the screen, instead of having the far sight students show up on the screen. How do I do that? Well, we used to be able to do it. Well, I've never tried it with Zoom. This is the first time I'm trying it. Doesn't let, okay, all right. Well, then I'll just go with what I got. All right, bye. All right, so we'll just go with what I got. Okay, so The difference between a sine and a cosine is literally where I start. And if I'm doing it in my calculator, one is going to start at 0 and one is going to start at 1. They're going to be off by 90 degrees of each other. Now, that's important because our book is going to define simple harmonic motion by using the cosine function. Your lab, when you guys start lab, is going to use the sine function. It doesn't matter. It doesn't matter because all we're dealing with is what we call a phase angle. It just does not matter with respect to that. So that's one of the things that we have to kind of look at our sine and our cosine. And if you need to kind of go back and review that for a little bit, I would suggest you do so. Because we're going to be dealing with sine and cosine as describing this wave function. And that's what it's called. It's called a wave function. Because essentially what we have is a sine wave in time that's looking at the position of our little red box in time. This is going to tell us an awful lot of information. This sine function is going to give us a great deal of information. It's going to give me the frequency at which I'm bouncing up and down. It's going to give me the period of the bounce. It's going to give me the amplitude of the bounce. And I can actually read all of that just by looking at the graph. I can read all of that looking at the graph. So let's look at this for a second. Okay, we're going to look at this for a second. I've got, if I'm looking for period, period is the time that it takes for one complete cycle. So if I'm looking at this and I'm over here on my graph and I see that I've got this at the peak of the bounce and it tells me I'm at 2.85 seconds, and then I come over here and I find that exact same point in this waveform right there and it says it's 3.56 seconds, my period is the difference. So I do my 3.56 seconds minus my 2.85 seconds. I'm going to do 3.56, right? That's a 3.56. I had 3.56 minus 2 what did we say, 85?
0.85.
So the period of that oscillation, so simple harmonic motion can also be referred to as an oscillation. The period of that oscillation right there, right now, was 0.71 seconds. So I already found all kinds of information from the graph that told me it was going at 0.75 seconds. Well, that's cool. Okay? So I can do that. And we know that the period is equal to 1 over the frequency, or the frequency is equal to 1 over the period, right? It's something we've been beat into in physics and chemistry class. We've been beat into it since we were little, because my frequency is in hertz, and the unit of hertz is 1 over seconds. My unit of hertz is 1 over seconds. Period's in seconds, frequency's in 1 over seconds, so period and frequency are directly related. So in order to do the frequency, if I want to do the frequency, I'm just going to take the inverse of that, and my frequency is 1.4 hertz. My frequency is 1.4 hertz. Now, the way I've got this graph set up right now, I don't necessarily, because I looked at acceleration, okay? I did this in terms of acceleration. We can do it in terms of position, and we can do it in terms of a few other things as well. If I do a position graph, let's see if I can do a position graph. If I did a position graph, I could get the amplitude. And just so that you know from a definition point of view, amplitude, you can see that there's a hash line in here that's kind of bisects our graph. The amplitude is the deviation from that central zero to either the maximum or the minimum. Amplitude is not peak to trough, okay? Amplitude is not peak to trough. Amplitude is from that equilibrium point to the maximum or the equilibrium point to the minimum. So we can actually look at, so we can get a whole lot of information, and when we come back on Friday, because I'm sure brains are full and we've had a lot of technical difficulty today, and I really want to be able to draw stuff, I will actually show you how to write out the wave function for that particular piece, or be able to pull the information, if I give you a wave function, be able to pull that information out. So I'm going to stop there because I'm tired of fighting technology. We got a lot done today. And any questions, anything that needs to be covered before we
What would you call peak? What would you call peak?
Peak to trough?
Yeah.
Peak to trough is from the upper, so peak, this would be peak, and that would be trough.
Yeah, what would that be?
That's 2 times the amplitude. Yeah, that's 2 times the amplitude, that distance there. Okay? All right, we'll get back on Friday. You guys over here will have the facilitator on Friday. I'll be over in Enid on Friday. And Robin, I'm gonna reboot the room.
I'm in room 102 now, I moved, but I'll sit here for a little while so we can play with it.
Well, I think it's my room, not yours.
Oh, okay. Again, I think they're supposed to help me.
All right, we'll see you in a bit.
All right, bye.